Doing nothing is the symmetry operation E. C2 operation. When C2 operation is done once, we are rotating the molecule for an angle of 180 degree. When the C2 operation is done twice for getting the identity element E. Why you are getting the identity element E? Say for example, I am having the water molecule. So this is the water molecule. Let me say this is hydrogen A and this is hydrogen B. And this is the axis of symmetry. When I rotate the molecule about this axis for an angle of 180 degree, that is C2 is operated once. When C2 is operated once, I am getting the configuration O, H, H, and A comes over here and B goes over there. This is the identical configuration. Now, when you perform the same operation again, that is C2 operation is done again, now you are getting the molecule where hydrogen A comes over here, hydrogen B goes over there. Now, this structure and this structure are not identical configurations, they are the same configurations. Therefore, I can write the C2 operation done twice will be equal to the identity operation E. Just a minute. Some network problem I'm experiencing. Just a minute, wait. I will be online now. Suppose if you take a C3 operation, C3 operation done once, C3 operation done second time, that is, this is for 120 degree rotation, this is for 240 degree rotation. When C3 operation is done thrice, this is for 360 operation, this becomes again E. You can understand this.
Board clear, sir.
Board, it will get focused when I am away. Is it visible now? It's autofocus. Because of the autofocusing, is it clear now?
Blur 3, sir.
Okay. I don't know how to focus it. Okay, right, we will do it again. Or tomorrow I will send you a written paper so that you can understand.
Okay, sir.
Okay. Now look here. See, boron trifluoride molecule. When the C3 operation is done once, let me say this is A, this is B, this is C. When C3 is done once in this direction, I am getting boron. Again, fluorine comes over here, fluorine comes over there, fluorine here. But this A will come here, this B will go there, this C will come here. When the C3 operation is done twice, for the second time, I am doing the operation for the second time, then boron, fluorine, fluorine. By this time, A will be here, B will be here, and C will be here. When it is done for the third time, C3 tries, I'm getting boron, chlorine, 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 A. Therefore, these two configurations are the same configurations. Therefore, I can write C3 thrice equal to identity E. C3 thrice is equal to identity E. Now, if you take the platinum Cl4 2 minus complex, platinum Cl4 2 minus complex. This is a square planar complex. So in this square planar complex, this is C4 axis, the axis which is perpendicular to the plane of the blackboard is the C4 axis. Therefore, C4 once. Let me designate this is A, this is B, this is C, and this is D. C4 once in this direction. I am rotating the molecule about this direction. C4 once, platinum. I am getting the 4 chlorine atoms in these positions, and their positions are changed like this. A comes over here, B goes over there, C here, and a D here. This is for C4 once. So when you do it for C4 twice, C4 twice, what will happen? C4 twice can be written as C2 once. Try to understand this. Try to understand this. C4 axis, when the operation is done twice, that is equal to C2 operation done once. Are you able to understand? C4 means 90 degree. C4 90 degree. I am doing the C4 axis 2 times. Therefore, what will happen? You are rotating the molecule for 180 degree. So, what is the symmetry operation for 180 degree? C2 once. Therefore, I can write C4 twice is equal to C2 once. Therefore, I can write C4. What are all the operations present in C4? C4 once you can do. Instead of C4 twice, you can write it is C2 once and then C4 thrice, and the C4 4 times will be equal to E. Try to understand this. Try to understand. Actually, the camera auto-focusing is working. That is why when I am away, the letters are clear. Therefore, the C4 operation, when it is done once, it is C4 1. When C4 is done twice, it is equal to C2 once. If when C4 is done for third time, it is C4 thrice. Then C4 is repeated for one more time, it is E, the identity. Are you able to understand? So that is the symmetry operations. Now the other operations, look here. I request all the students to mute your phones or laptops. Similarly, sigma. You can take the sigma operation. I have already explained what is sigma. Sigma V is the vertical plane. Sigma H is the horizontal plane. When sigma V is done once, it is reflection. When sigma V is done twice, what will happen? You are reflecting and again reflecting, you will get the identity element E. No change. When sigma H is done once, okay, there is a reflection. When sigma H is done twice, you are reflecting and again reflecting, therefore you are getting E. Now, we have already discussed what is improper axis of symmetry. I have explained that with a model. You might have seen the model of allene. Allene molecule contains improper axis of symmetry. What is improper axis? A rotation followed by a reflection about a plane which is perpendicular to the rotational axis, which is called improper axis. And I have already told you, Sn is the improper axis. Sn is equal to Cn sigma. That is, n is the order of the axis. It is rotated, that is Cn rotated and then reflected. I can explain this so that you can understand. See, this is the allene system. I suppose you understand the allene structure. So these two hydrogens are in the plane of the blackboard, and these two hydrogens are perpendicular to the plane of the blackboard. That means this hydrogen is projecting towards the viewer, whereas this hydrogen is projecting away from the viewer. Now I am rotating this molecule for an angle of 90 degree. I am rotating the molecule for an angle of 90 degree. What will happen? You will be getting the structure like this. See, in original configuration, on my left, the two hydrogens are in the plane of the blackboard. On the right, one hydrogen is projecting towards the viewer and the other hydrogen is projecting away from the viewer. When it is rotated for an angle of 90, on my left, the hydrogen is projecting towards the viewer and the other hydrogen is away from the viewer. But on the right, two hydrogen atoms are in the plane of the blackboard. Now these two configurations are not identical. They are not identical. Because if you want to get an identical configuration, the left carbon should have the hydrogen which is in the plane of the blackboard. Therefore, what I am doing, I am taking a plane here. This is a reflection plane. That is the reflection plane. And in this plane, I am reflecting this half part here and this half part there. So when the reflection is done, I am getting the configuration CH, CH, C, H, H. Now I am getting the identical configuration. Identical configuration I can draw here so that you can see that C, H, H, C, H, H. Now this is the identical configuration after reflection. This part is reflected over there and that part is reflected over here. Now I am getting the identical configuration. Therefore, I can say this is C4 rotation and then followed by a sigma, C4 rotation and followed by a sigma. Therefore, as a whole, I can represent this like this. It is S4 axis, where S4 axis is C4 sigma. S4 axis is a C4 sigma. Now, this S4 axis can be done for 4 times. If you look here, I am going to elaborate this one. When the S4 axis is done once, S4 once, I am performing this action once, S4 once, I am getting C4 once, sigma once. Is that right? Watch closely. When S4 is done once, I am getting C4 once and a sigma once. When S4 twice, I can write like this. This is equal to C4 twice, sigma twice. C4 twice, sigma twice. C4 twice is nothing but C2 once. Is that right? C4 twice is nothing but C2 once. So C4 means a 90 degree rotation. 90 degree rotation is done twice. Therefore, 180 degree rotation. 180 degree rotation means it is a C2 axis. Therefore, it is C2 once. Whereas a sigma twice is E, identity E. Anything multiplied by identity E will reproduce the original element. Therefore, this is equal to C2 once. Therefore, I can say if S4 is done twice, it is equivalent to performing C2 once. Now, S4 thrice. S4 thrice means it is C4 thrice and then sigma thrice. So, what is C4 thrice? C4 thrice is a C4 thrice. Sigma thrice can be written as sigma square and a sigma 1. So sigma square or sigma twice is E. Therefore, it is C4 thrice E and then sigma 1. C4 thrice E and then sigma 1. Therefore, E multiplied by anything, it won't change the value of the other components. Therefore, it is C4 thrice sigma. So for the S4 thrice, this can be expanded like this. Now, S4 4 times can be written as it is C4 4 sigma 4. So this can be again written as C4 4 sigma 2 times and sigma 2 times. What is C4 4? When you rotate a molecule C4 for 4 times, you are getting E, and the sigma two times is also E, and another sigma 2 times is also E, and as a whole this is equal to E. So this is how the S4 axis can be expanded. In order to make you understandable, I would like to explain this again. S4 1 and the S4 axis. S4 is a 90-degree axis, and when S4 is performed once, it is a C4 once and sigma once. When S4 is operated twice, S4, the rotation, improper axis rotation is operated twice, you are getting C4 twice and a sigma twice, and the C4 twice means C4 is a minimum angle to be rotated to get the first identical configuration is 90 degree, therefore it is performed twice, therefore 180 degree, therefore one single rotation which is equivalent to C4 twice is a C2 once. So sigma twice means it is reflection and again over reflection, therefore it is E. Therefore C2 once multiplied by E will give you C2 once. Therefore S4 twice can be directly written as C2 once. When S4 thrice, it is C4 thrice and sigma thrice, and C4 thrice, sigma thrice can be written as a sigma 2 times into sigma 1. Therefore C4 thrice, sigma 2 times is E and then sigma 1. Therefore as a whole this can be written as C4 thrice sigma. Now S4 4 times can be written as C4 4 sigma 4, which is C4 4 sigma 2 times into sigma 2 times. C4 4 is E, sigma 2 times is E, and another sigma 2 times is E. Totally E multiplied by E multiplied by E is equal to E. So this is how an operation can be expanded. Now we are going to the real group theory. The symmetry operations present in a molecule will form a mathematical group. First of all, you should understand what is a group. Group means a set of members or set of entities which have the following characteristics. First characteristic, I have already in the last class I have told you what are the characteristics of a group. First characteristic is closure. It should obey the closure rule. Closure. What is closure rule means? Any two elements of the group should combine to result in the third element, which should also be a member of the group. And the second axiom is the group should contain an identity element which should combine with all the elements of the group. That is the existence of identity element E. And the third axiom is every element of the group should have an inverse element, where suppose A is an element, when you combine with its inverse, that should result in the identity element. This is the third one. Fourth one, the operation should obey associative law. If it obeys the associative law, what is associative law? Suppose A star B star C, I'm doing the A star B first and then star C next. This should be equal to A star B star C. I'm doing the B star C first and then A star. If this condition is satisfied, then the operation is said to be associative. And apart from these four characteristics, if it has one more characteristic, that is, if all the elements of the group commute, commute means A star B is equal to B star A. This is called the commutation, B star A. If all the elements of the group commute, then that group is called an abelian group. Abelian group. And there is one more type of group. If sixth property, if one element of the group generates all the elements of the group, it is called a cyclic group. So all the cyclic groups are abelian groups, and all the abelian groups are groups. But all groups are not abelian groups, and all abelian groups are not cyclic groups. You can take down If it is visible clearly, you can take down. So the first rule, closure property. Second one, the existence of the identity element in the group. Third one, the existence of inverse element of all the elements in the group. And the fourth property is that the function should be associative. And apart from this, fifth property, if all the elements commute, then it is called an abelian group. And the sixth property, if any one element of the group generates all the elements of the group, then it is called a cyclic group. Now, I am going to construct the simple multiplication table to prove that the elements of a set form a group. Look here, x power 4 is equal to 1. What are the solutions for this equation? X power 4 is equal to 1. So the solution, x can be 1, minus 1, I, and minus I. 1, minus 1, I, minus I, they form a group. I'm going to prove that these elements form a group. In order to prove that these elements are forming a group, you have to construct a multiplication table. Multiplication table is constructed like this. 1, minus 1, I, minus I. Here also 1, minus 1, I, minus I. The function is multiplication. The function is multiplication. So I'm going to multiply it, and I'm going to multiply and fill all the boxes. First box can be easily filled. 1 into 1, 1. 1 into minus 1, minus 1. 1 into I. 1 into minus I, minus I. Similarly, here the first column also can be easily filled. Minus 1 into 1, minus 1. I into 1, I. And also minus I into 1, minus I. Now this box, minus 1 into minus 1, 1. Minus 1 into I, minus I. Minus 1 into minus I, it is I. Now I into minus 1, minus I. I into I square. I square is minus 1. I into minus 1, minus I square, therefore this is plus 1. Now minus I into minus 1 is plus I. Minus I into I, minus I square, therefore plus 1. Minus I into minus I is plus I square, it is minus 1. Now the entire column is filled. Now look here, all the elements in these boxes are members of the group. No new element is found. All the elements in this box, they are the members of the group. Therefore, the first rule is satisfied, closure rule is obeyed. Second one, there is an identity element which commutes with all the elements. One is the identity element for multiplication. Therefore, it commutes with all the elements. Therefore, the existence of identity element is also there. Third one, each element should have its own inverse element. Inverse, see, minus 1, its inverse is minus 1. For I, its inverse is minus I. For minus I, its inverse is I. For 1, its inverse is 1. Therefore, all the elements are having their own inverse elements in the group. Therefore, the third condition is also satisfied. And the fourth condition, associative law. Multiplication is always associative. Therefore, that is also proved. And also here, all the elements commute with each other. Therefore, see, for example, I into minus I is 1. And also minus I into I is also 1. Therefore, all the elements commute. Therefore, the 1, minus 1, I, minus I, they form an abelian group. They form an abelian group. And also you can generate all the elements from I. See, I power 1 is I power 2 is minus 1, I power 3 is minus I power 4 is plus 1. Therefore, all the elements of the group are generated from I simply by changing the power. Therefore, the generator of this group is I, and also this is a cyclic group. This is how the group is proved. Therefore, the set containing 1 minus 1, I minus I, they form a cyclic group. So, now taking the chemistry part of the group theory, the symmetry operations present in a molecule, they form a group. So all these properties will be found in a group. Now let us discuss. Let us discuss the symmetry operations in the water molecule. Now you have to watch very carefully. Water molecule, it contains the symmetry operations E, C2, sigma V dash. EC2 sigma V dash. And I have already told you the various positions of these symmetry operations. So the C2 is here. This is the C2 axis. And a plane is also there. That is the sigma V1, sigma V. Another molecular plane where the molecule can be cut into two thin sheet-like structures. That is sigma V dash. Both are vertical planes because both the planes are containing the principal axis. Now, the symmetry operations in the water molecule, they form a group. We have to prove by constructing a multiplication table. Now, how to construct the multiplication table for the symmetry operations present in the water molecule? So, I am constructing a multiplication table C2, sigma V dash, and E, C2, sigma V dash. So E is the identity element which will commute with all the elements of the group. Therefore, the first row and the first column can be easily filled. C2 sigma V dash. Now look here, this place. First you write, I write it here. Take the water molecule. This is A, this is B. First write the operation in the column. Second write the operation in the row. You are performing this operation first. Watch closely. First you are writing the operation in the column. Second you are writing the operation in the row. You first perform this and then perform that. So when you do this, you are rotating the molecule once, B goes over there and A comes here. When you do this operation, again A comes to the original place and B comes to the original place. Therefore, you are getting the same configuration HAB. Therefore, C2 and C2 will combine to give E. C2 and C2 will combine to give E. Now, when I do the second operation, you will thoroughly understand. Watch closely. Watch closely. First, you write a water molecule A, B. As I said, First write the column operation, then the row operation. First write the column operation, then row operation. First perform this one, sigma v. When you perform sigma v, you are going to reflect about this plane. Therefore, O, H, H, A will be reflected here, B will be reflected there. You must understand the difference between rotation and reflection. Even while rotating, you might have mentioned like this. When C2 axis, when you are rotating, B goes over there, A comes over here. That is what we said. Even here also, A is shown here, B is shown there. Then what is the difference between sigma V and C2? In C2, when the molecule is rotated, the back portion comes to the front portion, and the front portion goes to the back portion. That is how it is rotated. But when it is reflected about this plane, front remains front, back remains the back, but the position is changed. So this is, look here, suppose this is the front portion of the hydrogen, front portion of the hydrogen. There is no change in the front, but just left and right positions are changed. So this is the thing. Suppose, let me say this is the front portion. Let me write this is also the front portion. But now I perform the C2 operation on this. When I perform the C2 operation on this, the molecule is rotated. Now hydrogen A comes over here, sorry, B is here, A is there. But look here, these two configurations are not the same configurations, because while rotating, the front becomes back now. Front becomes back now. Even though the position of hydrogen A and hydrogen B are in the same position in the new configuration, the front has now become back. Now we have to identify what is that one single operation which may cause this. What one single operation will give you this configuration from this configuration? That one single operation is sigma V dash. What is sigma V dash? You are cutting the molecule into two thin half sheets, where the front is reflected over the back and the back is reflected over the front. Therefore, what will happen? A will remain in its own place, B will remain in its own place. But only thing is the front portion will be reflected in the back and the back will be reflected in the front. That is what we have got here. So hydrogen A, hydrogen B, where is the front? Where hydrogen A, hydrogen B, they are all remaining in their own place, but it is the back. Therefore, one single operation corresponding to sigma V and C2. When sigma V and C2 are combined, that can be performed by one single operation, sigma V dash. So here you are getting sigma V dash. I suppose you are understanding this. Now I will try with the next one so that you will understand. So for the next one, you are writing the column operation first, sigma V dash, and then the row operation C2. What is the one single operation corresponding to these two? That is what we are going to find out. I am performing the sigma V dash once first. What will happen? Suppose this is the front portion. Sigma V dash is the molecular plane, where the molecule is cut into front and back and they are exchanged. So the resultant configuration will be like this. A will be there, B will be here, but this front, now this is back. This is front, this is back. Because the reflection plane is the molecular plane. We are cutting the molecule into two thin sheets and we are reflecting the front to back and back to front. Therefore, the position of hydrogens will not be changed. Only thing is the front and the back are changed. Now I am performing the second operation, C2 once. So C2 once means it is rotating like this. Now what will happen? The hydrogen A will come here, hydrogen B will go there, but at the same time the molecule is rotating, no? While rotating, the back will become the front. So what will be the one single operation which is corresponding to this? So front remains front, but A and B are interchanged. What is the one single operation that we can assume, which is the reflection plane, this sigma V? When you reflect about this plane sigma V, A will be reflected over here, B will be reflected over there, but the front will remain in the front. Therefore, sigma V dash and C2 combined together will result in sigma V. So that is how the third, this box is filled. Therefore, remaining you can do. I can do the next thing also, so that you can easily understand. So the next box, column first, row second. I am writing the water molecule. I am performing the C2 operation. Let me say this is the front portion. When it is rotated for an angle of 180 degree, you are getting the new configuration. A comes over here, B goes over there. Now the front becomes back while rotation. Front becomes back while rotation. Let me say it is